Scott, you can hear me, please?
We sure can. You sound great.
Okay, good. So I will start. I need to. Okay, it's coming. So the idea of today is to speak about how long do we spend on doing testing, and why it is so low. So it is a basic evaluation of how long I spent when I was a tester and when I am a tester of doing testing. So this is the testing part where I actually do test, and the rest is a lot of time, and it's when I'm not doing test. You might know this situation, and from my point of view, my experience, this time is mostly due because we're waiting. We are waiting for basically the environment. So we are waiting for the environment to be deployed, the application to be deployed in the environment. We are waiting for the application to be working, because since it's deployed, it's usually not working. We are waiting sometimes for our data, so we are requesting someone to find us data for doing our test, and it takes time to have to do interaction with guys, with other teams. And at least we are usually waiting for the environment to be repaired, because someone did something on the environment which was working, and now it is not working anymore. So waiting time is a lot of time. And this waiting time, in my experience, was pain, fear, anger. Let's say it was the dark side of testing. My evaluation of this, my thoughts are, we are waiting because we are not testing well. We are usually doing testing, end-to-end testing. We want to do end-to-end testing. And this is, from my point of view, the reason why we're waiting so much for environments, for data, and things like this. Let's have a look on this virtual ecosystem. Each letter is an application, and you see there is links between these applications, and it is, let's say, dependencies between these applications. If we want to test the A application, we will have to get some of the ecosystem working. Here is a shopping list of the ecosystem we need it to work if we need to do testing. That's quite a lot. If you consider each application is probably managed by a specific team, has a particularity regarding release and things like this. So if you want the application A, C, D, G, and M to be consistent, to have the correct version, to have the correct data in each database, you will have to wait a lot of time. And that's quite simple because it's a virtual one. A lot of ecosystems I've seen are really, really more complex. And just on this one, think about testing B. If you have to test B application, you will need to have almost everything up and running with correct version, correct data, things like this. And on testing environments, we always have a part which is never working. It has never been set up, so you will always have some problems. All of this comes from the fact that we are doing end-to-end testing. My purpose today is to talk about isolating your application and do component testing, what we call component testing, and do it in dynamic environment. So what are our goals? So we want to isolate our application under test. It means we want to remove any external dependencies. We want to control our application under test availability, stability, the version, and we want to have control and to decide what are the data we are using in our environment. So we want to have exactly the data we need to do our tests. So that's our goal. What should we do in your situation? We have kind of application isolation shopping list, which is basically made of 5 elements. First of it, you need to orchestrate everything, because everything we will want to do here, we need to do it automatically, so it has code, so you need an orchestrator. I will do a demonstration later in in the presentation, and the orchestrator I'm using is Jenkins, very known one. Second, you will need to find a way to create your environment, your infrastructure from nothing. So it's what we call infrastructure as code. You can do it in VM, you can do it in bare metal machines, but you have to be able to wipe this machine each time you need to rerun your test. For the demonstration, I will do it in the cloud. I will use AWS, but you can use whatever cloud or whatever solution you have in your situation. It's more the principles that are important. Third is you need to control your data, and part of your data are usually into your application, into database. So you need to think about it, because it's usually the trickiest part, the more difficult one, is how to set up a database for my environment, for my test application, which I control. I need to be sure of what data are in it, and I don't want, for instance, when I do test automation, I don't want these data to be modified by any manual testers or any external application doing its own test and propagating its data to mine. You need to think about isolating your application from external applications. So for this, we will use an external service stubbing system. In my demonstration, it will be Bountybank. You should have a look on Bountybank, which is a very useful tool and very easy to use and free on the MIT license. It's quite strange. If you go to the website of Bountybank, you will find the website is quite strange, but that's normal. That's on purpose. But it's very, very, very simple to use, and I will explain it later why it is very easy to manipulate this as a tester. And last but not least, of course, you need to have automated tests. And all of this will take place for our example or previous example. If you want to test A and isolate application A, you first have to remove everything except A. Then you will have to add everything I've listed on the left. So I mean, first the orchestrator, the infrastructure as code. Then you will have to put your database, your mocking service, and at the end, your test. Of course, you want to do everything of this as code. So I'll show you a short video, which is 3 minutes long. So keep awake because it's quite fast, showing this demonstration and how we can do it in Jenkins. So this is my Jenkins pipeline. I'm using here BlueOcean because I prefer the view of BlueOcean. I need the video to run. Okay, so yes, my pipeline is now running. I will show you quite fast. So here you will see that I'm doing many things on parallel, but basically I will create the host, then deploy onto the host my application, and then do my test. I'm showing you the tool I'm using to provision my database. This tool will allow you to use a virtual database, and you will see in less than 20 seconds, I will create a database which is more than 4 GB big. So in 10 seconds, it has been created. So it's part of my infrastructure creation. I'm creating a database with already set data in it. This is my AWS console. So you see my machines are creating. I'm creating an application server, and I'm creating another server on which I will put Bountybank. It takes some minutes. As soon as it is created, I will deploy on it my application. So everything is scripted to deploy my application. And I will do the same with Bountybank, which is the stubbing service. When it's done, I will be able to run my script. So I have an environment, fresh, clean environment built from nothing, with already set data in my database. And in my testing script, I run my test. And before running my test, I will publish, and I will show it to you later. I will publish my data to Bountybank. When it's done, here's my Source Lab console. You see that I have my application, my data are here. And if you have a look, I have my database size, which is almost 4 GB, the one which has been created in 10 seconds. So everything is here. My test is run. My test is really simple. But what we have seen is In less than 3 minutes, my full application stack has been deployed, plus virtual database, plus stubbing service. I was able to run my test, and as soon as it is done, everything is destroyed. So I don't keep anything like machines or things like this. I will pay here in my example in AWS, but you can do it anywhere in Google Cloud or Azure or whatever. I will pay only for the minutes I'm running my test environment. I'm also destroying my virtual database, which takes some seconds. And at the end of all of this, my environment is completely removed. So I build a complete brand new environment for my application A, isolating my application A to test it. Sorry, the video just paused for no reason. I hope it's working well on your side. Okay, it is. Okay, so it's at the end of the video. Just want to show you two print screen of my test project. So it is a basic test Java JUnit Selenium project, the one I'm using for doing this demonstration. What I want to show you is here I have in my data folder, I have my multi-bank configuration. So it means for the tester, for the estate who is doing your scripting, you're giving this person at the exact place where he or she build his test, you're giving him sorry, I will use tools. Where is? I'm looking for. I don't know where is. There it is. Sorry. So you're giving him the place where you want to store your configuration, and this is a configuration you have to send to multibank. So basically, you are explaining multibank on HTTP protocol and on port 3000. When you are doing a get on my profile, you want to answer a JSON payload. JSON payload with name, first name, and picture of people, and this is how you configure your backend. And in my test, this is my test, basic test I did. I only have to check it, to validate that the objects are present. So it's quite easy for the tester to have the ability to decide directly in his test project the data he need to have in the backend. So that's basically my presentation, the demo I wanted to show you. Let's go back to our slides and try to summarize everything. So what we did, we were able to remove all external dependency we have on our application, because we want to isolate completely it and to be able to test it. The idea is to remove any external human dependency you may have for any teams you may want to wait. You may have to wait for the other application to be deployed, correct version, and things like this. You are building something which is fully replayable. You can replay it as much as you can. The idea is to have something very, very predictable on your test environment. So you're basically removing some flakiness on your automated test. And last but not least, very important things, you are choosing the test data. So you don't have to expect someone to build or to forge some data in any backend that suit your need for testing. You are just doing it by yourself, and you decide what your backend should answer, and you are just replacing your real backend with mocking services. This is our main achievement, but we have side effects on this. When we're building a dynamic test environment like this, we are first of all having more velocity in our testing. So in our deliveries, we are really faster to do some development. We don't have to wait for other teams to be ready or other environments to be ready. You can really deliver faster your application. Something which is not our goal, but which is very interesting. When you are doing this in public cloud like Amazon, Google Cloud, Azure, or whatever public cloud, you have to think about you are paying only for the time your server is running. Just think about your end-to-end environment, end-to-end classic environment you may have on premises. You are usually using it something like 2 or 3 hours a day, not more. If you just have a look on when you use it during the full year, it's less than 2 hours a day, but you are paying it. You are paying your servers and things like this 24/7, 24 hours a day, 7 days a week for almost nothing. So here for the demonstration, you have seen that in less than 3 minutes, I had my full testing environment for my application A up and running, and my test lasts something like 20 seconds, but our average runtime on our side for doing automated testing is something between 20 to 1 hour. So when you are running this, you will pay for 20 minutes or 1 hour of service. Just think about it. Amazon Web Services machines and VM, it costs, the one I'm using, it costs less than 1 cent per hour. Well, it's something like 1 cent per hour. So it's almost nothing. So it's big savings at the end, even if it's not our purpose. We're more interested in having velocity. And last but not least, it's quite fun. It's quite fun to do this because you give control to your QA team, to their environment, and they feel more empowered, and that's quite interesting for them. Quick takeaways and shopping list. This is something I added today because last presentation I did, some people asked me how to do it by yourself. First of all, you have to think about how will you deploy your application. You have many tools, Terraform, Ansible, Dockers, or cloud infrastructures, or you may need to do it on premises. Think about it, but first thing to think about is how you will deploy your application. You need to be able to deploy your application as code, okay? That's the first thing. As soon as you will think about it, you will think about, okay, but what about external dependencies? My application is calling whatever web services or needs a database or needs file system and things like this. If you think about deploying your application into virtual, dynamic environments, you will think about it, and you have to think about it. So this is your second point to think about. Then you will have to orchestrate everything, and then it's only technical stuff. You will have to orchestrate everything in a pipeline, in a script, the way you want to do it. But something important is think about your human activities. When you will set up this, think about, okay, but my tester, how he will use it. And that's the way you should drive your things, because you need to think about where you, as a tester, you will need to provide the data you need, for instance, or provide any information required for doing your testing in your dynamic environment. Well, that's it. That's my point. Doing testing in dynamic environment is very, very useful. It may solve a lot of problems for you, but it has to be synced and to be done. Quick words about me. My name is Valentin Guerlesquin. I'm working at National Bank of Canada. I'm a French person, but I'm living in Montreal now. You have some information about what I like and don't. As many of you, I'm at home now, so but I have some support behind me. So this is Bernard Bernays, who is looking at your question now. I want to thank a lot Anthony Gauthier, who is one of my colleagues. He helped a lot to do this presentation, basically to build the application and the test to do the demonstration. And I need to thank him. I don't know if he's around, but let's say thank you, Anthony. And last, yes, I will answer your question in some seconds, but I need to notice you that there is a Slack channel for SourceCon today, and you can go and ask me any question and have some discussion about this on dynamic testing environments channels. But first, I will answer your question live, the one you may have given me on the chat. Scott, probably you can give me some.
Yeah, sure. There's a handful of questions. Can you hear me?
Yes, very well.
Okay, so the first one that came in was, how do you solve data issues? Data being available today, but not next month, or data variance between different test environments?
Okay, so that's the purpose of this. The idea is to solve this problem. If you have environments which are shared between different teams and things like this, you will definitely have this kind of issue. The idea is to create everything from scratch anytime you run your test. So anytime you do a code commit from your application, you want to have your, let's say, continuous integration, continuous testing, continuous deployment pipeline running. And in continuous testing, this is the purpose of the talk, you want to build your test environment from scratch. This is exactly the idea. So now how you manage to have the correct data. The data from the backend that I've shown you are in the test script. So it is managed directly by the tester. The data which needs to be in the database of your application under test, my recommendation is to have a separate database, a separate static database, which is available only for specific people, not accessible by a shared environment, on which you put the test data you expect to have on your environment when you will build it. And for instance, if you have a new kind of data, so I'm working at a bank, so I will talk about bank data. For instance, if you have a new kind of credit cards, a new product, you will have this kind of new product on your static database, which is your data source, and what we will call something like a golden record, okay, golden copy. And when you will spawn your test environment, you need to do a kind of copy of this database to provide a fresh new copy of this database to your testing environment, on which you can do whatever you want, because it's okay, it's a database that will leave something like 10 minutes or 1 hour and destroy everything at the end. But at the end, you still have your data source, which is known, and any tester can know what is in this data source, because you need it to do your test, and you will be sure that these data won't be destroyed. If someone needs new data, he has to insert new data in it, not to modify the one which are existing.
Okay.
Right? Yeah.
Next question is, how brittle is mocking when the application changes in some way? How can you defend against delivery happening too fast for you?
Oh, I need to read it. I'm not sure to understood it.
Okay, well, maybe we could take that one over to the Slack channel.
Yes, please. There's a person who just asked this. Please go to the Slack channel. I will discuss more about this. Sorry.
Sure. There's another question that said, is the deployment pipeline created by QA alone, or is it done by devs/DevOps? Okay, the team of Service Code Online today this week is basically testing better together. Of course, in these days, we have a lot of problem by working together at work. Anyone is at home. And that's basically a very good theme, very good motto, because of course, you don't expect a QA tester to be able to build everything from scratch, building a Jenkins pipeline and using AWS. Probably you will need to have collaboration of the rest of the team. And that's the purpose of testing. You're not supposed to be alone on your side. You have to work with your development team. You have to work with the guys, usually we call DevOps guys, but the guys who do pipeline and things like this. It is a teamwork to achieve this kind of things in a development team, in a delivery team. So that's basically, you need to do it together, of course. Okay, I see one other question. When you have mocked services, do you somehow verify if mocks are still valid based on changes in services?
Oh, okay. That's a very interesting point. Too many organizations don't have strong interface and contract services between service they provide internally. That's a big point. And if some people are changes, for instance, some teams need to change the service, an exposed service, too many organizations don't apply feature flag, don't apply retro compatibility and things like this, and it will be a mess if you expect everything working but someone is modifying everything everywhere. So of course you need to enforce a kind of respect of contracts you have between any application, because if someone is making a service evolving and you are not noticed about this, your mock will not be it won't be accurate anymore, and you will be testing on something which is not supposed to work like this. So it is obviously something you have to talk about. But you obviously have the same problem if you're doing end-to-end testing. The problem is usually the reason why also you're waiting, because you're just deploying an application that doesn't work anymore with other applications because someone changed the service and did not notify you. So changing a service is good as soon as you ensure version control and retro compatibility. But if you don't, yes, it's a mess.
That is all the questions we have at the moment. If you'd like to go ahead and wrap up.
Yes, don't we have another question right now? It's good?
Yep.
Nope.
I don't see any others that haven't been answered.
Okay, so thank you for coming. Thank you for your time. Please join a Slack channel if you want to discuss furthermore about this. I'll be happy to answer to you. Since I'm in Canada right now, my time zone is not the same from guys from Europe, so I can stay late for you if you want. I'll be happy to answer you. Thanks a lot, and see you next time.